cholinergic agonists and antagonists. Naturally, depolarization of presynaptic cell membrane opens the calcium channels, which allow the influx of extracellular calcium ions toward neuronal cytoplasm. Calcium ions, in turn, stimulate the release of acetylcholine neurotransmitters from their intracellular storage vesicles. The released acetylcholine molecules traverse the synaptic clefts to bind to their postsynaptic receptors and exert their biological effects. Cholinergic antagonists are agents that have similar binding sites to acetylcholine molecules and can bind to their postsynaptic receptors. However, these cholinergic antagonists do not activate the acetylcholine receptors, and instead they render them inactive. Additionally, they inhibit the binding of acetylcholine molecules to their receptors. Cholinergic antagonists are classified into muscarinic blockers and nicotinic blockers. Muscarinic blockers inhibit parasympathetic system. These agents include atropine and scopolamine. Nicotinic blockers block the ganglionic nicotinic receptors and neuromuscular junction. Ganglionic blockers affect both the sympathetic and parasympathetic systems. An example of this group is hexamethonium. Neuromuscular junction blockers block specifically the somatic innervation of the muscles. This group includes atracurium and cisatracurium. On the other hand, cholinergic agonists bind to cholinergic receptors and exert similar response to acetylcholine. The main group of cholinergic agonists is direct cholinergic agonists, which are either muscarinic agonists, which stimulate the parasympathetic system, or nicotinic agonists, which stimulate the ganglionic receptors. Examples of muscarinic receptor agonists are pilocarpine and bethanicol. The most famous example of nicotinic receptor agonist is nicotine. Another less famous nicotinic receptor agonist is acetylcholine. After the completion of its job, acetylcholine molecules diffuse through synaptic clefts, where they are degraded by the acetylcholinesterase enzyme. A group of agents called acetylcholinesterase inhibitors can bind to and inactivate acetylcholinesterase enzyme. As a result, they increase the concentration of acetylcholine molecules at their postsynaptic receptors and indirectly activate the cholinergic receptors. Hence, they are called indirect cholinergic agonists. Indirect cholinergic agonists are classified into reversible inhibitors, which are often used as therapeutic agents such as hydrophonium, or the irreversible inhibitors that are famous with their serious negative biological effects, such as organophosphate groups.